Okay, let's talk about RxJS operators. For a lot of us, just hearing that phrase feels like you're staring into this dense, overgrown jungle. But what if I told you there's a map? A simple guide to navigate that entire landscape. Today, we're going to draw that map together. Let's turn all that confusion into some real confidence. You've been there, right? Staring at the official docs, just scrolling and scrolling through this list of over 100 operators. You're left wondering, do I need merge map or switch map? Should I use throttle time or debounce time? It's a classic case of just being overwhelmed by too many choices, and that's exactly what we're here to fix. But here's the thing. What if you didn't have to memorize every single one? What if instead you just had a mental map? A framework that lets you navigate this whole thing with confidence so you can find the perfect tool for the job fast. Well, that's the map we're building today. So, any good map has a starting point, right? A big landmark that divides the whole world. For RxJS operators, that landmark is this one simple idea, the difference between value and time. This single concept, it literally splits the entire library right down the middle.
Pretty much every single operator you're ever going to use falls into one of two camps. You've got value-based operators, which care about the content of your data. They transform it, they filter it, they combine it. Then you have time-based operators, which care about the flow. They control when that data shows up. It really just boils down to what versus when. This is the first and most important fork in the road.
All right, so let's take our first trip. We're heading to the value continent on our map. Honestly, these are the operators you're probably going to be using most of the time. Their whole job is to shape the data that's flowing through your streams. But even on this big continent, there are different regions to explore.
So here on the value continent, we find our next big landmark, the line between lossy and non-lossy operators. A lossy operator is basically anything that might reduce the number of values coming through. Think of filtering things out. But a non-lossy operator, it guarantees it won't drop a thing. It'll either transform each value one for one, or it might even expand one value into many.
So what does a lossy operator actually look like? Well, filter is the classic one, obviously. Or maybe you'd use take one to just grab the very first value and then you're done. Distinct until changed is another great one for cleaning things up. It stops duplicate values from coming through back to back. And of course there's reduce, which is like the ultimate lossy operator. It takes a whole stream of stuff and boils it all down to just one single value at the very end.
Now, on the flip side, you've got your non-lossy operators. And the king of this category is, of course, map. It's your classic one-to-one transformation. For every value that comes in, exactly one value comes out. Then there's scan, which is kind of like reduce's cousin. It also keeps a running total, but it emits the result at every single step, which makes it absolutely perfect for managing state over time without losing any of the history. Okay, this brings us to what is probably the biggest headache for anyone learning RxJS: merge map, concat map, and switch map. They're all non-lossy, but they have totally different strategies. The easiest way to remember them is by their personality. Merge map is the eager one. It dives in and does everything all at once, in parallel. Concat map is patient. It waits for one thing to finish completely before it starts the next, so it always keeps things in order. And switch map? Well, it's ruthless. The second a new value arrives, it cancels the old one. It's perfect for things like type-ahead search bars. Okay, let's pack our bags. We're leaving the value continent and traveling to the other major part of our map, time. If the value-based operators were all about shaping the what, then the time-based operators are all about mastering the when.
Just think of these operators as being like traffic control for your data. They're the traffic lights, the roundabouts, the speed bumps, all for your asynchronous events. They couldn't care less if the value is the number 5 or the letter A. Their only job is to manage how fast things are happening, maybe delay them or group them together based on time.
Let's paint a picture here. Imagine a user typing into a search box. Without any control, you're just spamming your server with network requests for every single keystroke. It's a disaster. But if you add debounce time, 200 milliseconds, the operator just waits. As the user types search, it sees every letter, but holds back. It's only after the user stops typing for 200 milliseconds that it finally sends the last thing it saw. It's a beautiful way to handle back pressure.
And look, debouncing is just one tool in the toolbox for handling a flood of events. You've also got throttle time, which is amazing for stopping people from double-clicking a button. It lets the first click through, then just ignores everything for a short period. Audit time is kind of similar, but it emits the last value from that ignored period. And then there's sample time, which just peeks at what the latest value is on a regular interval. Each one gives you a different way to control that flow of data.
Okay, so we've traveled across our entire map. We've seen how operators can shape the what and control the when. So let's bring it all home. How do you actually use this map day to day?
What this map really gives you is a simple set of questions to ask yourself anytime you're stuck. First, am I trying to change the data's value or am I trying to control its timing? If the answer is value, your next question is, do I need to maybe get rid of some values, making it lossy, or do I need to keep every single one? And if the answer is timing, you ask, okay, how should I deal with this flood of events? Do I need to debounce, throttle, or sample? This little decision tree will point you to the right neighborhood of operators every single time.
So look, the goal here is not to memorize 100 different operators. Please don't do that. The goal is to understand the map, because if you can just remember those core divisions, value versus time, lossy versus non-lossy, you will always know exactly where to look. When you understand the landscape, finding your destination is easy.
When you have this model in your head, RxJS stops being the scary, intimidating library, and it becomes a logical, predictable toolkit. It just gives you a really powerful way to think about asynchronous streams. So with this map in your head, what tangled piece of code are you going to go simplify first?